Hello everyone. Welcome to SWAM online lecture series on the topic database management system. Myself, Muhammad Ubadullah Bukhari, working as a professor in the Department of Computer Science, Aligarh Muslim University, Aligarh. I am pleased to have you join me today again as we explore the fascinating realm of data, databases, and database management system. In the next few minutes, we will discuss about the techniques for tuning and optimizing Oracle databases. In the previous, I've already discussed installation, how you'll install, about the Oracle's configurations, backup and recovery. So before going to discuss today's agenda, I want to give you answer of the previous questions which I have asked in the previous lecture. The first question was, explain the importance of database configuration in Oracle database administration. The answer is, database configuration is crucial in Oracle database administration as it directly impacts performance, security, and scalability. Proper configuration involves optimizing memory allocation, defining table space, and configuring network settings to suit the organizational workload. Security considerations such as user privilege and roles are also the part of configuration process, ensuring the protection of sensitive data. The next question of the previous lecture was, discuss the key components of a robust backup strategy in Oracle database administration. The answer is, a robust backup strategy in Oracle includes regular full and incremental backups using Oracle Recovery Management, RMN. It should incorporate considerations for off-site storage, ensuring data integrity, availability in the case of disasters. Point-in-time recovery options and through testing of backup and recovery process are critical components to minimize downtime and data loss. The third question was, how does routine maintenance contribute to the long-term health of an Oracle database? The answer is, routine maintenance takes The answer is, routine maintenance tasks in Oracle database administration play a vital role in sustaining the database performance and stability. Regular patching and updating ensures that the database software is current with security fixes and bug patches. Ongoing performance monitoring and tuning identify and address bottlenecks, while tasks like index rebuilds and statistics gathering optimize database efficiency. Health checks and system audits proactively detect potential issues, preventing them from escalating. The next question is, how can you optimize the performance of an Oracle database through routine maintenance tasks? The answer is, performance optimization in Oracle involves routine maintenance tasks such as index rebuild, statistics gathering, and regular system audits. Identifying and resolving bottlenecks through monitoring and tuning is essential. Additionally, optimizing SQL queries, managing a storage space efficiently, and keeping the database software up to date contribute to sustain high performance. So the agenda of today is to discuss about Overview of performance tuning. Why performance tuning master? Why performance tuning matters? Common performance challenges. Goal of performance tuning. Introduction of data tuning. Next is important of database tuning. How database tuning is important. Understanding of bottlenecks, performance bottlenecks, advantage of techniques for tuning and optimizing Oracle database, and the last is disadvantage of techniques for tuning and optimizing Oracle databases. So first we will discuss overview of tuning. Performance tuning in database management system refers to the process of optimizing the performance and efficiency of database operations. It involves identifying and addressing bottlenecks, inefficiencies, and other factors they may impact the speed and responsive of database queries and transactions. Performance tuning aims to improve query execution time, reduce resource consumptions, and enhance overall system throughputs and enhance overall system throughput. This may involve various strategies such as indexing, query optimization, schema design optimization, caching, and configuration tunings. The goal of performance tuning in database management system is to ensure that the database system can handle increasing workloads efficiently while providing users with fast and reliable access to data. Now we'll discuss about why performance tuning matters. Simply, performance tuning refers to the process of optimizing software applications to enhance their speed, efficiency, and resources utilizations. But does performance matter so much in the world of software? In the fast-paced digital landscape we inhabit, users have come to expect lightning fast responses from the applications they interact with, whether it's shopping on e-commerce websites, playing a game on the mobile devices, or conducting financial transactions online. User demand a smooth, seamless experience. Slow or inefficient applications can quickly frustrate users, leading to dissatisfaction and even abandonment. It's not just about user experience, there are tangible financial implications as well. Business that neglect performance tuning may find themselves facing increased cost due to the need for additional server resources, higher bandwidth usage, and ongoing maintenance efforts. So let me discuss some common performance challenges. These could be slow query response time, high resource utilization, inefficient SQL queries, and we can say suboptimal indexing and misconfigurations. Then we'll discuss about the goal of performance tuning. There are various goals of performance tuning. You can see on the screen. Goal performance to make a database faster but to enhance overall system speed, minimizing response time says. minimize response times, to optimize resource utilization, ensure scalability to manage workload, create a finely tuned database environment, scales seamlessly with the organization growth. Let's some key components of performance tuning. These are the keys: strategic implementation of indexing, efficient memory management. These are the key components of performance tuning. And the third is judicious system configuration. It means each facets play a vital role in shaping the overall performance landscape of database. So now if we talk about the introduction of database tuning, so then we can say database tuning refers to the process of optimizing the performance and efficiency of a database system. It involves adjusting it involves adjusting various parameters and configurations to ensure that the database operates smoothly and efficiently. Database tuning aims to improve query performance, reduce response time, and enhance overall system throughput. One basic example of database tuning is index optimization. Take about index optimization. An index is a data structures that improve the speed of data retrieval operations on database table. By creating index on the column frequently used in queries such as primary key or column used in where clause, the database can quickly locate and retrieve the required data. For instance, consider a table of employee record with a column of employee ID. Take an example. By creating an example on the employee ID column, the database can efficiently locate the record of a specific employee when we queried. Depending on the requirement, we are able to query by employee ID. This is the introduction of database tuning. So, we can explore the advanced techniques that can elevate our skill as a database administrator, allowing you to fine tune Oracle databases for optimal performance. So, come to the point importance of database tuning. On the screen, you can see that enhance performance, optimize resource utilization, cost cost saving. By that we can, these are important of database tuning, and the better user experience, scalability, and the last is reliability and availability. So these are the important of these are the importance of database tuning. Enhanced performance means to faster query execution, reduce response time, and improve system throughput. Optimize resource utilization means resources utilization can be optimized, including central processing unit, memory, and disk storage. The next important of database tuning is to cost saving. Cost saving by reducing the need of additional hardware, upgrade, or infrastructure investment. Better user experience, it means improve the system responsiveness, enhancing user satisfaction and productivity. Next is scalability. Database tuning lays the foundation for scalability by ensuring that the database system can handle increased workloads and growing data sets without significant degradation in performance. Last is reliability and availability. Tuning the database helps optimize its reliability and availability by reducing the likelihood of system crashes, downtime, and data inconsistencies. So, database tuning is not one-time task, it is an ongoing process that evolves with the changing demands on the system. With each system updates, application modification, or shift in user behavior, the performance characteristics. The next topic will discuss about the understanding performance bottleneck. Understanding performance bottleneck is a database management system involves identifying and addressing the factors that limit system performance. These bottlenecks can occur at various levels of database architecture, including the hardware, software, and databases. So these are the hardware limitations, software configurations. Hardware limitations means by one example we are able to understand. Suppose a database server's CPU is consistently running at maximum capacity during a peak usage hour, causing shutdown in the query process. Then the solution bottleneck identification, monitoring such system matrices such as CPU utilization, memory usage, disk input output, and network bandwidth can help identifying hardware bottlenecks. In this way, I'm taking example how hardware limitations there, then the software configuration issues, then there's example and the bottleneck how it will come. For software configuration, example after inadequate database configuration setting such as insufficient memory allocation or improper buffer pool size can lead to proper query performance. Bottleneck identifications we can do analyze the database configuration parameters and monitoring system logs for error and warning can reveal software related bottlenecks. Database design flaws. If performance of bottleneck will come due to design flaws. Inefficient database schema design, such as a lack of proper indexing or denormalized tables, can result in slow query execution and high resource consumptions. The bottleneck identification, analyze queries, execution plan, and identify long-running queries can help pinpoint design-related bottlenecks. Next is concurrency issues. Concurrent transaction competing the resources such as logs on the database objects can lead to contention and performance degradation. How you identify the bottleneck? Monitoring logs weight, deadlocks, and transaction throughout and transaction throughput can help identify concurrency related bottlenecks. Last is data volume and distribution. Large table with million of rows and uneven data distribution across database partitions can impact query performance and resource utilization. How you identify bottleneck? Analyze the table size, data distributions, statistics, and query execution time can reveal data related bottlenecks. So these are about how to understand performance bottlenecks. Oracle provide several tools for identifying performance bottlenecks such as Oracle Enterprise Manager, OEM, and Automatic Workload Repository, AWR. These tools generates reports, and matrices that help administrators understand the current state of database and identify areas that require attention. Then think about the advantages of techniques for tuning and optimizing Oracle databases. Enhance performance and responsiveness, optimal resource utilization, and by fine tuning. Optimal resource utilization means advanced tuning techniques allow for optimal resource utilization, addressing performance bottlenecks related to CPU, memory, and input output. By fine tuning the database configuration, administrator can ensure that resources are efficiently allocated, preventing resource connections and improving overall system stability. Scalability for growing workload. As organizations grow, so do their data requirements. Advanced tuning techniques enable Oracle databases to scale seamlessly to accommodate growing workload. The cost optimization and by eliminating performance bottleneck. Cost optimization means effective database tuning can contribute to cost optimization by maximizing the use of existing hardware resources. By eliminating performance bottleneck and that ensure efficient resource utilization, organization can delay or eliminate the need for costly hardware upgrades. Next topic is disadvantage of techniques for tuning and optimizing Oracle databases. Complexity or learning curve, as it often requires a deep understanding of database architecture and intricate configurations. Risk of over-tuning mean, for example, aggressive indexing strategies may enhance certain queries but could adversely impact write performance. So, striking the right balance between read and write operations and avoid over tuning queries, careful consideration of a specific workload characteristics and business requirement. Here you can see few more disadvantage of tuning and optimizing Oracle databases. Resource intensiveness, as it may require downtime and careful planning. Potential for data inconsistencies, for instance, modifying a query to improve performance may alter the expected results, leading to the data inconsistencies. It is crucial to thoroughly test changes and ensure that optimization effort do not compromise data integrity or or the accuracy of query result. In today's lecture, we discussed about the database tuning. Now let's assess your knowledge and track your progress with few thought-provoking questions. Your answer will not only reinforce your understanding but also serve as a valuable gauge of your grasp on the crucial topics discussed today. The first question is, what is one potential challenge associated with the complexity of implementing advanced tuning techniques in Oracle database? The next question, how can overtuning become a disadvantage in the context of Oracle database optimization? In what way can resource intensiveness be potential drawback when implementing advanced tuning techniques? What is potential risk associated with data inconsistencies when optimizing Oracle's databases? This is all about today's lecture. Thank you for being there in this session. I will look forward to you in the next session. Thank you.